All right, guys, so today we're going to get into a very broad area of statistics that's going to involve a lot of different situations later down the line as far as what type of problem you have, whether it's a mean problem or a proportion problem, and we even get into different type of hypothesis testing for different types of distributions, and it gets really nitty-gritty down the line. But right now, this is just an overview to kind of give you an idea of what the point of hypothesis testing is, and mainly how you know whether or not you're dealing with a one-tailed test or a two-tailed test. That's one of the main things I've seen students that I would tutor struggle with, is just given the problem, identifying what type of hypothesis we're talking about here. So it's important to know that in hypothesis testing, you always hypothesize about a population, okay? So in our variables video explaining the population variables versus the sample variables and everything like that, you have to keep in mind that when you set up your hypothesis, you always use the population-based variables. So if we're hypothesizing about a mean, we're going to use mu. If we're hypothesizing about a proportion, it's going to be based on what variable your professor says to use. I've had some say pi, some say p, but overall, the population-based proportion, etc. So anything you put in when you're hypothesizing about, never put in a sample variable. Please do not set up your hypothesis and put in x bar, which is the sample mean, or f, which is your sample proportion. It's just not the way you do it. We are using sample information to speculate about a population. So the hypothesis we're creating is about the population, and some people just get that confused because we use information from a sample to come up with our conclusions of whether or not we accept or reject a hypothesis, and that's just simply not the case. It's always going to be the population-based variables that we put into the hypothesis setup. So as far as setting up the actual hypothesis itself, there's just a standard setup you need to keep in mind where we have a null hypothesis, which is designated by HO, and an alternative hypothesis, which is HA. And sometimes I've seen it as H1. Right now, we're just saying HA, okay? So when we're dealing with whether or not, like how we set up this hypothesis, how we do this hypothesis setup, we need to first decide whether or not we're dealing with a one-tailed test or a two-tailed test. So first I'll talk about a two-tailed test. So the way I like to think about a two-tailed test is using a number line. So I have a number line right here. And let's say in the problem, it's asking, I've seen this one before, where they're wondering what is the mean or the average vet bill received at this vet clinic in this town. So they sample however many people, they take all of their vet bills, add them up, average them, and you get some amount, okay? So we could be wondering, someone could tell us, okay, the average vet bill is $100 at our clinic. Okay, if I want to hypothesize about that, and all I'm wondering about is whether or not that is a true statement, what I'm wondering about is, okay, so we have a vet bill you're claiming is $100. If in the problem it says, create a hypothesis test about whether or not the mean vet bill is $100, okay? What that's saying is they're wondering, is it $100 or is it not $100? Is it 100 or is it anything other than $100? So it could be something greater than $100, could be something less than $100, because what the problem's asking is whether or not it is 100 or it is not a 100. It's like a binary yes-no notation. So I like to think about these ends of the number line as tails. So if I'm wondering about, it could be something over here, it could be something over here, whichever one, that is a two-tailed test. So when we kind of translate that to how we set up the hypothesis, let's just, and since this is a mean-based problem, I'm wondering about the average vet bill for this vet clinic, I'm going to use mu because mu deals with the mean of a population. We're not dealing with proportion or anything right now. It's just not the type of problem we're dealing with. So the hypothesis setup with HO and HA, you're going to say mu for both of them. And if we're wondering about $100, we're going to say mu either equals $100 or it does not equal $100. And you can see how that nice and cleanly translates down to this number line that we drew, because it either is 100 or it's not 100. It's something over here, it's something over here. Could be anything, right? So that'll kind of neatly transition us into how to do a one-tailed test. So we'll do kind of the same logic behind it. But let's say in this problem, they say, okay, the vet bill is $100, so that's their claim, right? And let's say I'm not wondering if it's exactly $100. So that is a bit of a strict thing to put on them, because if it was $101, technically they would be incorrect. But really, what I might be interested in is making sure that it's not anything more than $100, right? Because if you're telling me it's going to be 100, I'm thinking in my head, okay, awesome, it'll probably be around 100, hopefully less, but I definitely don't want it to be more, right? So if we're setting up a hypothesis for a one tail, and they're wondering about, is the average vet bill more than $100. That is what I'm wondering about is it more than 100? In this situation, I don't care if it's less than 100. I'm talking about is it more, and that's the nature of the question. The way we're going to set up our one-tailed test, so we're still hypothesizing about mu, and we're still talking about 100, but what we're saying here is that, okay, I'm interested in it being greater than 100. What you wonder about is what you're going to put into your alternative hypothesis. So I'm going to say, is it greater than 100? So we'll say greater than 100 here, and then you can just simply flip it, and it's going to be less than up here. And one important thing to note that I almost forgot about is that when you're setting up your one-tailed hypothesis, you want to make sure that in the null hypothesis, when you do a greater than or a less than, say equal to. So whether or not it's greater than or whether or not it's less than in the null is the one that's going to have the less than or equal to or the greater than or equal to, whereas the alternative is just going to be wide open. It doesn't have an equal to associated with it. So that should give you a good overview on how to set up a hypothesis test. Obviously, given the different types of problems you have, whether it's a mean or proportion, and lots of things later down the line is going to affect exactly how you set it up. But this is kind of a good introduction to how you should set that up. If you can remember these number lines right here, where if we're wondering about is it this or is it not, it's talking about two different considerations, right? Whereas here, if I'm concerned with one direction only, whether it's greater than something or less than something, that's going to be a one-tailed test right there, and that's how you set that up. So I hope that helped.